Thanks a lot for coming and listening to what we're going to, what I'm going to show you. I mean, witnessing the code. I'm going to do a demo, but I'm going to start by, explain how we've been using the system that we're open sourcing within the firm, so that you can see. It's a pretty big system. We are open sourcing everything at the end, but as part of the trial, we're going to show a subset of the system, so it is pretty easy for people to use, especially that we're pushing everything outside of our environment. So there's something that are more or less tricky to push, so I'm going to go for that. So what we're using Pure for in Goldman, so we're modeling things. So we're modeling concepts that people are working with in the banks, and we're making sure that they're interconnected. So it can be like any kind of concept. We model credit cards, we model credit default swap, we model employees, we model pretty much everything and all information we have in the firm so that people can actually navigate it easily. So this model that we have that enable navigation, we do many things with them. So we map them to infrastructure because we want to make sure that our models execute. It's not only about a matter of like showing nice pictures to people to communicate. It's also about using the models to retrieve information and to play with information. The models can also be valuable if you don't map them to databases. Like, for example, when you want to define really complex schemas for derivatives or really deep information that you need to store in documents, the models are really valuable too. Our platform does that a little bit more advanced than usual because we can also support constraints to do validation. We can support some derivations actually in the model. We can support mapping from model to model so that you can transfer a structure of information you have in one environment to another environment. So once we get these models that are actually mapped to systems, what we can do is actually provide APIs actually for people to use the data. So it can take many forms. So we have tools that I made demo at the end that let people self-serve on information. So they have a model of information they can understand. They can drag and drop the information they want to transfer or to access actually in our system. They execute and they can retrieve the information. So a lot of business users are using this way to acquire information in the firm. We can also build data services so that if it's not a person that wants to self-serve and get information and we want to automate actually the retrieval of information in the firm, like we can say, well, this information that I described this way, can you build a service and after system can connect and acquire data through these services. So to give you like an idea of the usage, we have 1,000 people in the firm actively modifying domain, like the domain and the model. So I'm not speaking of people developing the platform, which is my team, which is a subset, but all the entire community of developers in different business units publishing and showing models about the information that they work with every day and interconnecting this information together. We have around 2,000 SVN commits. And I'm speaking about SVN here. We're working with GitLab actively on the new version that actually I'm going to demo. The current version in production is using a proprietary SDLC that we have in our firm that is actually backed on SVN. But like the modification we're doing right now as part of open sourcing is to move to something more open, which is GitLab. We actually aggressively release the system every day. So whatever modification we do, reach productions really, really quickly. So there's a test strategy on modification that is fairly heavy, where any kind of modification in the environment is going to run through tests for any modification at any point in time. So we have a batteries of servers that ensure continuously that the metadata is actually doing configured the right way to achieve the goals that people want to have when they enter information in the system. We have around 62,000 classes. So classes is kind of a building blocks of a model. So concept managed in the system right now, as of yesterday, because I wrote that yesterday. We have around 3,600 mappings. And mappings are this relationship we have between the models and database or model to models themselves, if we want to translate from one model of representation to another one. We actually have modeled 2,156 databases. that represent 14,500 or 600 tables. So that's all this kind of infrastructure information that people enter that we map to concept in our environment. So the system is used a lot in T+1 reporting. So if we want to transfer information and publish information outside the firm or even inside the firm, to be fair, but also in the trade flow. So we have models that are defined that represent information that are actually acquired and executed as part of the trade flow in the system. It represents, without the trade flow, 18 million execution a day. So there's 18 million queries that goes to the system to get data, retrieve data, and actually move them in our system. So it's used a lot, actually, in our environment, and we're really excited to move it outside and to make sure that we can actually work with you on models and on platforms. So that's it for the presentation. So today, users interact with pure writing ASCII code. So it's really code-based that we commit into a proprietary SDLC, as I said before. As part of open sourcing, we build this alloy layer that allows us to have services and make the system modular around actually this pure engine that we defined. And we switched SDLC from proprietary to GitLab, actually, so that GitLab provides rich APIs that allows us to easily actually build integration with SDLC using UIs that are a little bit easier to use than a regular SDLC. So that said, I'm going to jump on the, I can speak a little bit about the positioning of the tool I'm going to demo you now in the ecosystem of tools that we're going to open source. We have Foundry, which is the IDE of models that I'm going to demo as soon as possible. Foundry can write metadata that goes to data browser, which is a browser that lets you actually and lets business users execute queries against the graph of information that we have that can go into a cube system. So people in finance, deep graph and complex structures go so far. A lot of people like to do grids, cubes, and pivots. So we have a system that simplifies actually the model for some of use cases of reporting that allow people to cube information. And we can actually go on a service environment that productize some of the queries and some of the specifications people defined to be able to get data. So I'm going to show you Foundry. So that's Foundry when you want to connect. The first thing you can do is pick a project. So these projects are behind-the-scenes GitLab projects that are covered by regular SDLC. So I'm going to go with an empty project and define a workspace actually I can work with, which behind the scene translates to a branch. But when you're a user, you don't really know that. You just see actually that you have a workspace you can work in. On top of that, so I can start to define models. So I have packages. Packages are important when you start to scale in model because they have a first layer of taxonomy that allow you to make sense of all the information that you have in systems. So I'm going to say main package. And I can start to define classes. And that's the building blocks I was speaking about from a model perspective. So I can say I have a person. I can define firm. Oops. So now I can go and say that firm is going to have employees of type person. So now I start to have a model of information that defines a graph. So I link concepts together. So it's not primitive types or varchar integers. They're actually types that actually let people express information and relationship in a way that is a little bit easier. Now I've been clicking and showing how to do this kind of like interaction that is more UI driven. So and we did that to open the modeling effort to operations people or people that are not technologists. Behind the scene, though, the engine that we have in Pure is still active. So we actually just edit code while we actually play on the UI. So you can pretty much, if you want, bypass the UI, go behind, and write actually specification in ASCII. So the interesting thing, we did that because one of the feedback we had from people is that it's all nice, your UI, but I want to cut and paste, I want to work with people, I want to actually be able to go faster. So that's why we keep both modes available for people to be able to quickly enter information or start to learn about the system by just dropping and clicking some concepts. So up to now, there's no real difference between what I show you and a regular modeling environment, like especially UML. I mean, it's really UML-driven behind the scene. What we start to do, which is not usual, is that you can define formal constraints and formal derivation and formal transformation. And we compile, actually, this kind of expression that you write in the system so that we can then translate them to different language of execution, Java, SQL, or whatever actually people want to execute these kind of things on. So I can define the constraints and say, for example, that the size of a company need to have greater than 2. I mean, it's kind of random. So this kind of expression is compiled behind the scenes. So if I make a mistake, for example, and I type employee the wrong way, I will have a feedback that actually the information that I entered is wrong. So same, if I decide to not return a Boolean expression, I'm going to have like, no, we don't actually support that. So because we enter actually this system of code, this system of potential execution, the SDLC is really key for us because it means that whatever we enter in this modeling environment will most likely have an impact on some computation that we actually define in our system or some data transform that is sensitive to some report or some like number that are fairly important. So we cannot really have a modeling environment that is really just about drawing pictures. It executes, it has to actually be governed by an SDLC. So what you can do too is define derivations. So I'll go quick on that, but you can define that some information is built out of other information. So I could say that. So in this case, I'm saying that employees is the first employee. The system tells me that the type I return is the wrong type because I said that it was a string, but actually it should be a person. So actually, I can change that. And I can compile, and now I have more information that I enter in the system. So now I can also add other types, like enumeration, which is a convenient type. So I can say that I have an incorporation type. And I can say it's an LLC incorp. So that's one of the types that can dynamically be created beyond the class. We're also going to add units and measures as part of the system for the release in January and for the test, so that derivatives like commodities can be modeled like more accurately. Like at this point, primitive types, if you enter units and measures, are not really necessary. You can at this point define things more accurately and saying, I have unit 5 and it's pounds, like for if you want to trade metals, for example. Instead of like having this information disparate in the model in a way people don't understand, we put that as part of the type system, build an algebra on top of it so that you can even build operations on this type and do automatic conversions. So again, like for derivatives and commodities, it's really, really convenient to have this kind of facility in the context of modeling. So you can do super types. We support multiple inheritance in the model. So you can actually define super type here. Legal entity. So you can actually, and you have a view for each actually operation that you do that gives you a synthetic kind of overview of what you've been editing in the model. You can extend the model using profiles. So if you have metadata that you want to enter in the environment, but we didn't think about it as part of our meta model, you can extend it. So you can do an extension, for example. And if you want to say, I want to add my documentation the way I want, I can add a tag, which is a doc. Can add a stereotype, it's important. So that's my extension profile. Now, if I go in the firm, I can say, let's add documentation. Let's pick this extension doc and say documentation for the firm type. So you can actually, and you can see like the synthetic view like changing with that. We can also tag with the important stereotypes that I showed you. So it's fairly powerful to be able to extend the meta model, extend the kind of information that you want to enter in the system, and later potentially use it and trigger it with compilers, because it can be then leveraged to impact the way we transform information behind the scene. So speaking about transform, so all the system, as much as I showed you like this view, which is a type view, and this view, which is more the ASCII view of everything I entered, compatible with the pure language, the native representation of the system is actually JSON. And you can interact and plug information in the system using services, using this JSON specification. Now, it's fairly interesting to look at and play with the UI, because you can actually start to learn about the structure that we create based on what input you enter in the system. But once you see that and you look at the API we provide, you can build your own tools to enter metadata and to contribute to the graph of information. We have use cases right now where some departments in Goldman have been building their own UI and their own way to enter metadata in the same repository, contributing to the graph, but with a different kind of interface, not using maybe a power tool like this one, but something simplified in the context of mortgage management or something like that. But you can also start to use transformation that give you like transformation in other language. So for example, what does it look in Java? Everything I entered. Well, like you have the Java code that is representative of what I just typed. And also, what does it look in Slang? So Slang is our internal language that we use. But we use actually code generation to be able to interface and integrate actually with this environment. So if I go back on the form side, Ivia. So now, I've been modeling things, but what do I do with that? So one use case that we have a lot is mapping. Okay, so if I want to edit a mapping, well, before that, I'm going to show you diagrams, because again, these kind of tools are really important for communication. So building pictures and a layout of information and its correlation is really, really key. So if I want to show a diagram of information I just had, I can just create a diagram and just say, I have my firm, I have my legal entity that I had behind, and you can navigate actually the diagram directly in the UI. So I can say, well, this person here, extract it. So I extract my person, and I can see that my person has employees this way. Here I see actually when I did my diagrams that I forgot actually to add properties in person, so that I can actually directly add the properties from the diagram. And add actually first name, string 11, last name. Oops. So now I can actually use that. So this one is really simple. I'm going to show you, I hope, after models that are more complex that comes out of derivative, where really having the layout is key, like giving a big picture for communication, for definition, to spread the information. We found that diagram was one of the most efficient, actually, way to push information. Now I can actually add a mapping. And that's when things start to be cool. Where I'm going to add a simplified employee, let's say. I'm going to say that that has a full name. So now I can go in my mapping and say, if I wanted to map my simplified employee, okay, it's going to ask me what I want to map to. So pure means that I'm going to map to another model, which I'm going to show, but it could be also an operation, like a union of different mappings, or relational, which would go actually to a database and do transformation here. But let's say I want to map to pure, which is another model. I can go there and say, okay, I want to map that to person. So if it were a database, on the right side, I would see table and joins and things like that. Here, I see actually types and properties. And I can see that my full name here is what the property of simplified employee I want to map to. Now I can drag and drop and say, okay, I want the first name, I want the last name, and I want to concatenate them. Again, all these things are compiled expressions. So, like again, to show you, if I change them, it's going to tell me it is not working. And now that I get my mapping, the next thing I want to do is is to start to test it. First, to be able to have feedback about what I enter, to see that, does it do what I want to do, but also to write unit tests that we're going to run going forward to validate that whatever platform change we do or whatever underlying infrastructure we modify, we continue, doing the transform that you expect to do. So I can actually say, oh, let's try to execute the simplified employee and pull the full name. Now, it's going to tell me like, oh, I can generate for you some test data, though it's kind of tricky, like generating test data is never a good idea, but at least it gives you a feel of what actually input you can have behind the scene. And now I can even execute this transform and get the result, okay? So, and I can say, well, you know what, that's not really nice to see, so I can add actually an expression to perform the transformation. So you can see like I can get direct feedback out of the metadata I enter. So what you can see is that it's not only about playing with metadata and doing pictures and things like that. It's something that we use as part of execution flow. Most of our transform, actually all of our transform middle office to back office on derivative are defined actually with this transformation language when we want to communicate and transform actually information from one to the other, from a reg perspective, from a clearing perspective. So it's actually something that, where I show you a really simple example of execution, it can extend to really deep graph-to-graph transformation that actually push data outside the firm and also sometimes inside the firm. So again, because we have execution, SDLC is key. Without the SDLC stack, we could not actually guarantee, and I can show you, like, I've been modifying things here, and you can see that I have a counter that shows me everything that I've modified up to now that has not been synced with my branch. I can decide actually to sync it with the branch. And now I'm synced with the branch. Actually, I pretty much committed into the branch on the GitLab side. I can actually start to build a review out of the change that I did and actually push to production. So, that's where GitLab has been really, really transformative for us. Being able to actually have an SDLC that provide APIs that lets, this kind of interaction that are not usually code interaction work with us has been really, really key. And I'll let Ashish speak a bit more about like the effort that they're doing on the financial side, on the GitLab side.
Let me put it this way, let me ask you, like, why is, you talked about your traditional SDLC that you were using, and now you're using GitLab. In financial sector, there's lots of regulations, and you need to record everything. How's GitLab helped you in a perspective, like out of the box, that you haven't had to build? That's something that's
the thing. Like when we had Pure and we had people interact, with code that was code environment that was actually pretty complex for people to think, how do I interact with this environment? We build Alloy, and Alloy is this service layer around Pure. GitLab is kind of this service layer, I would say, I would find around an SDLC that in our proprietary stack we didn't have. So being able to say, okay, I will actually have my code committed, I will have tests running, I will have a pipeline of build that go on the information, but still give that in the hand of a business user is something that we were not able to do until we had this set of API that give us pretty much the full stack, like going from modification, committing, testing the build pipeline, pushing to actually our own repositories, trying to have this code depend on other code. And that's all this ecosystem that bootstrap us and make it pretty possible for us to move the code outside the firm. And I don't know if you saw, but the URL that I'm using right now has nothing to do with Goldman. It's actually pushed in the FINOS environment with a GitLab instance that GitLab installed for us in the FINOS space. So it's pretty much already totally decoupled from our infrastructure. And that would have been like years of engineering if we had to do that, not using a strong tool that is actually performing that at the industrial scale.
That was my question. And what's interesting is GitLab is actually based on open source, open core model. And for you to build actually something on it and contribute to it is the power of this conference and why we are here. I'm not going to talk a lot about GitLab per se because we have a booth outside. I would love for you to come and speak to us. But commonly asked question is what's the difference between GitLab and GitHub? Like that's the question we're getting at our desk a lot. I'd love for you to come and kind of find out more. Two big differences are, we kind of like cover the entire software development lifecycle and not just the repos, like Pierre talked about here. So come and know more about us. And secondly, we are an open source based company, which means our customers, which includes Goldman Sachs and a lot of you, are actually contributing back to the code. And that's how we're actually building out the entire SDLC. So I think we're at the end of time. I just want to leave you with a little teaser, and our team members are here. Come and know more about us, and we'll be happy to talk to you about it.
Thanks a lot. Thank you for attending.